everyone. Welcome to our session for statistics and probability. This is your teacher Liz saying buckle up because we'll be having a trip to a place where you are meant to reach. As we begin our discussion for today, please bring with you your self-learning module on statistics and probability under the topic of regression analysis. Scratch paper and pen. For our first activity, let us have a short stop on a place of identification, where the concepts of describing variables, whether it is continuous or discrete, is being recalled. For your task, you will be given 5 seconds, every given random variable, and determine whether it is discrete or continuous. Okay, so for number 1, the distance traveled by the car. So what's your answer? That's correct. The answer is continuous random variable. How about for number 2, the body temperature? Okay, you got it right. The answer is still continuous random variable. How about for a number 3, the number of teachers in the school can be counted. So what's your answer? That's correct. The answer is discrete random variable. So let's go for number 4, the length of service in the company. It talks about time, correct? So the answer is continuous random variable. You are correct. For the last item, time elapsed. The answer is continuous random variable. Alright, congratulations everyone for doing great on our first stop. In our second stop, you'll find a partner to accomplish the task. Because this task goes with the saying that 2 is better than 1. This activity will give us an idea on the type of variable used in the study, whether it is independent variable or dependent variable. For the instructions, you're going to supply the missing independent variable with a given dependent variable. Again, supply the missing independent variable with a given dependent variable. Okay, first, the dependent variable is the scores in the exam. What is the independent variable? Again, the dependent variable is the scores in the exam. What is the independent variable?
If your answer is one of the possible answers listed above, then you got it right. It could be that the possible independent variable when you have your scores in the exam is the correct answers that you got from the test, or maybe the test items, or the amount of time allotted for you to.
Second, the dependent variable is a first semester rating. Again, the dependent variable is a first semester rating. What is the independent variable?
For the item on the first semester rating as a dependent variable, the possible independent variables are the following. It could be that your quarterly grades affect your first semester rating.
For number 3, the dependent variable is the distance traveled by the car. Again, the dependent variable is the distance traveled by the car. What is the independent variable?
For the distance traveled by the car, the possible answers for independent variable could be the following. First, gasoline, or the amount of gasoline. Second is the time traveled.
Okay, before we're going to go to the heart of our topic, let us check if your SLAs are still there by raising your hands with it. Activity 1 and 2 allow us to rekindle our knowledge on the type of variables, whether it is independent, and the type of random variables, whether it is continuous or discrete. As mentioned earlier, our topic for this morning is to explore the concept of regression analysis. As for your task, at the end of the session, you are expected to predict the value of the dependent variable given the value of the independent variable. To give you direction on our discussion this morning, I want you to take a look at the image flashed on your screen and observe. What are the possible variables involved here? Which variables are dependent or independent? Write as many as you can. Based on your answers, the most frequent variables observed are the time and the battery charge. Which of the two is the independent variable? And which is the dependent one? That's right. The independent variable is the time and the dependent variable is the battery charge. Now take a look at the next slides. What do you think is the most relevant question here? Perfect! The question may be, when will the phone be fully charged? Are you excited to discover it on your own? If yes, then let's proceed to our next activity. For this task, you will become an analyst. With the time as our independent variable x and the battery charge as our dependent variable y, your goal is to predict the time when the phone will be fully charged using the data given. This time, I want you to get a piece of clean paper and pen and help me construct the table of values for our data. Let x be the time and y be the battery charge of the phone. The initial time you observe the phone in low battery is 9:02 in the evening at 5% level. What will be our first x and y pair? That's right. At time t is equal to 0, our battery charge is at 5% level. So our first pair is 0, 5. After 8 minutes, battery charge is at 14%. After 12 minutes, phone is charged at 19%. And later at 9:26 in that same evening, the phone is at 33% level. Thus, when will the phone be fully charged? Allow me to illustrate the plotting of points that we have in our table. It is expected that the phone will be fully charged at 100% level. The points you can see denoting the 0, 5, 8, 14, 12, 19, and 24, 33 is what we have in our table. What geometric figure can you draw? Right, it is a line. What is the equation of the line? Can we use it to predict the possible time our phone will be fully charged? What do you think is the exact time when the phone will be fully charged? Let us recall that the equation of a line is given by y equals mx plus b, where m is the slope and b is the y-intercept. In regression, the equation that describes how a variable y is related to a variable x in an error term e is called a simple linear regression model. The simple linear regression model is given by y equals b sub o plus b sub 1x plus e, where y is the predicted value, b sub o and b sub 1 are the parameters of the model, and e is the error term. So when you save by parameter, these are values taken from the population itself. The error term is a random variable that accounts for the variability in y that cannot be explained by the linear relationship between x and y. To further simplify our regression model, from y which is equal to b sub o plus b sub 1 of x plus a to y which is equal to b sub o plus b sub 1 of x, where y-intercept is a b sub o and the slope is a b sub 1, and the error term in the equation is being omitted for some reasons. The error actually allows us to be as human as we are, to make mistakes. And thus, when using the regression model, it is given that the prediction is not or may not be 100% true. For the error term illustration, let us view the following simulation. The solid line that moves from one point to another are the possible regression models given by y equals b sub o plus b sub 1 of x with the respective errors. The further the line goes from the data points, the bigger the error becomes. Note that the error term is the square differences of the observed values and of the points on the moving line. To estimate the regression or simple regression line, we are going to use the least squares method. The goal for this method is to make the square differences of the observed values and the predicted values as small as possible. The least squares method is given by the following formula. For b sub 1, again b sub 1 is our slope, which is given by the summations of xy minus the summation of x by the summation of y over n all over this expression here, summation of x square minus summation of x quantity square over n. And for the b sub o, again b sub o is our y-intercept that is being solved by the mean of y minus the value of the b sub 1 here multiplied by the mean of our independent variable x. Hence, for our next activity, you will be on the shoes of the programmers. You will be using the mentioned formulas to do the task. It is required that for an easier computation, a laptop with an Excel installed in it shall be used. For the instructions, you will be given the actual data on charging the phone up to its 95% level. The goal is to estimate the regression line equation using Excel.
Okay, so to estimate the regression line equation using our Excel, all you have to do is to open your Excel, Microsoft Office Excel, and then you can see here the data. Hopefully you have input the data already before you begin with the estimation. So we have the data here, time x from 0 to 100, that is in terms of minutes, and the battery level from 5% to 95%. Okay, so first thing that you have to do is to highlight these values with the respective pairs. Okay, and then you click insert, go to the scatter plot diagram. You click this one. Okay, so you can actually change the title of your presentation or the scatter diagram from time, for example, time versus the battery level. Okay, so that's it. The next thing that you want to do is to actually see the trend line here. So just click any dots, then right click for that one, then add the trend line. Okay, so the trend line shown is actually in terms of linear. Okay, so after that one, you have to find the display equation. Okay, display equation and chart, and then display r squared value and chart. So it will appear here the equation of the given data, equation of the line, where the slope is given by 0.9578 and the y-intercept is given by 10.65. Okay, so as simple as that, you can have your regression line equation. But if you want to really find out how to do this one without using the scatter diagram, you can actually recall that our regression line is given by y equals mx plus b, where m is the slope and our b is the y-intercept. Okay, so slope, recall that slope is given by the rise over run, so we can just use the function of slope, and then that is known y values and also known x values. So first thing that you have to input are the y values from 5 to 95. Okay, and then second is followed by the time from 0 to 100. Okay, Okay, and then enter. So here it is, our slope is given by the value of 0.95778. Okay, you can actually confirm this value here in your trend line. Okay, so under the illustration of the scatter diagram, for the y-intercept, that is equal to the intercept, function of the intercept, and then again you click the y values from 5 to 95, and also the x values from 0 to 100, and then enter. So that's it. You have your y-intercept given by 10.6496.
For the next activity, you will be using your previous estimated regression line equation to forecast the time when phone is fully charged. For the instructions, the goal is to predict the time when phone will be fully charged using the estimated regression line on your previous activity. You will be given 5 minutes to do this one. This moment, let us have the actual data simulation of phone charging with its best fit of line. What's your predicted time when phone be fully charged? Do we have the same answer? Let us find out through this one. The red line here indicates the level of the phone being charged. The points that you can see are actually the charging time with its battery level, and the last dot here or point indicates when the phone is fully charged. The best fit of line is indicated by the blue arrow or blue line rather, with an equation of y which is equal to 0.69x plus 20.99. And the answer for the question on when the phone will be fully charged is here. The cell phone was fully charged after 140 minutes. How much time passed when phone has been fully charged? The answer is 2 hours and 20 minutes or 140 minutes. And that time is exactly 11:22 in the evening.
So finally, for the performance task, you have to research on the Philippines data on the COVID-19 daily cases from the whole month of June 2021 and make a 3-day forecast of the COVID-19 cases on the month of July 2021. After this, you have to create a possible recommendation to the government based on the results of your estimation. And later on, for the purpose of comparison, you have to compare your estimated value or the predicted value to the actual value of the cases for July 2021.
So thank you so much for listening to our session in statistics and probability. Before I'm going to end this session, I would like to leave you this kind of thought that remember, when predictions are made, they are based on present conditions or on the premise that present trends will continue. These assumptions may or may not be proved true in the future.